So a lot of that stuff that I mentioned there in the first video, not easy to understand. Let's go breaking it down, right? So they are your learning outcomes, what we're going to learn. So our listing outcomes here, the list or set of all possible outcomes in an experiment is called the sample space. So when I talk about an experiment, I don't mean like, you know, getting my stuff in a science kit and blowing up things or that. Well, to a degree, of course, that is an experiment. But when we're on about probability, we're on about flicking a coin. Is considered an experiment. Flicking a coin, or maybe rolling a dice, is considered an experiment. So flipping a coin, you have two outcomes, heads and tails. Rolling a dice, you have 6 possible outcomes, 1, 2, 3, 4, 5 and 6. So there are different ways of finding the elements of a sample space. And what a sample space is just the outcomes. So when you flip a coin, the outcomes are heads or tails. That's the sample space. Done. Right? So systematic listing is one of the first ways of finding this sample space, or basically your outcomes in disguise here. So like a standard 6-sided die is thrown, list all the possible outcomes. So when I list them, I just write them down. And they are, when you throw a die down, your outcomes are 1, 2, 3, 4, 5, 6. That is writing them down. That is it done. That is systematic listing finished. That's one way of representing a sample space. The sample space there being 1, 2, 3, 4, 5 and 6. Now, if I move on here, another way of representing outcomes, or another type of sample space, is what's known as a two-way table. And in a two-way table, look at this, it's pretty cool, two-way table. So Emma has a choice of pizza, chicken or fish for her main course. So shorthand names for them, which would be very useful in a two-way table. P for pizza, C for chicken, F for fish. Yes? Yes? And we've got, she can choose either a juice or water to drink. So, in terms of juice, J, water, W. And just be careful if you ever have two things that are the same, pizza and pasta, you might have to give one of them 2 letters. Like pizza might be PZ or something and pasta might be P. I don't know. So list all the possible meals that she could order. So when I go to do this, here is my two-way table. We've got 2 ways represented. We've got kind of all the drinks and all the foods. All the drinks is one thing, all the foods is another thing. That's 2 things. But like people get confused in this because as you can see here, all the drinks, you've got 2 of them, juice and water. And all the foods, you've got 3 of them, pizza and fish. And you quite simply match them up. Pizza and juice, chicken and juice, fish and juice, pizza and water, chicken and water, fish and water. They're all our possible outcomes. Now I'm going to ask you here, how many types of foods do we have? How many types of drinks do we have? 2. What's 3 multiplied by 2? 6. Do we have 6 outcomes? Now keep that idea under your head there because that's the fundamental principle of counting done in a very quick way. But anyway, moving on, the last type of sample space that we have here is known as a tree diagram. And in a tree diagram, it's like, as the name suggests, it's like a tree. You've got branches. So a coin is flipped twice, given a head or a tail, show the outcomes. So we start off, the first flip, what can you get? Heads or tails. But then when I move on, if I did get heads the first time, now again, you've got to understand here, I'm not saying, oh, I'm getting heads. I'm saying that if I did get heads, so if I did get a head there, what can I get when I throw it again? No, I flip it again, I can get heads or tails again. You got caught. And that's what I said there. You thought, oh, you get heads first, you get tails. No. If I get a head, and we've done this in class a while ago, when I flip it again, totally independent flip, I can get heads or tails again. Right? But if I got a tail first, and I go to flip it again, I can still get a head or a tail with the new flip. Okay, so now all the possible outcomes, that's only setting it up. That's not getting you full marks. The full marks there, your possible outcomes are, you could have got a head first flip, a head second flip. You could have got a head first flip, tail second flip. You could have got a tails first flip, heads second flip. You could have got a tails first flip, tails second flip. And that's all the ways, by the way, of doing sample spaces. Whether you write down the answers, which can be very useful sometimes. Two-way tables are absolutely brilliant in representing problems. Brilliant, they're my favourite thing. And then tree diagrams are very useful in some ways.